So we have gone over trig functions in geometry, and I don't expect you to go, oh, yes, I remember all those. But I do expect you to go, oh, okay, sine, cosine, tangent, now I get it. But we got it. Okay, so we have a right triangle. We have any right triangle in the coordinate plane. But what quadrant did I only put in? What quadrant did I put in right there?
One.
The one. First quadrant. Okay, so we have some right triangle. And this is theta, my angle. It's called a central angle because it is around the origin. This distance here is your x value. This distance here is your y, because it's up and down, yes? And if I had this imaginary circle coming around that was in, what would this be?
Radius.
The radius. We're going to call it r. Now, when we did sine, cosine, and tangent in geometry, we did opposite, adjacent, and hypotenuse, which we will do it. But right now we're going to start in the coordinate plane, and so everything will be x, y's, and r's. Okay? X is the distance on the what axis? X-axis. Y is the distance on what axis? The y. We are always going to draw our triangles to the x-axis like I talked about the other day. So if I gave you an angle over here, it would come back to what? The x-axis. Okay? So we're going to just make kind of a table. We have sine, S-I-N-E. We abbreviate it. Sine of theta. We're just going to use theta for now. We abbreviate it S-I-N. We say sine still. We do not say sin. Every time you say sin, I'm going to make a tick mark and I'm going to take points away from your homework. Got it? Every time you say tan instead of tangent, I'm going to do the same thing. You say the whole word. Or I guess I could just make you write the whole word. Not bad for sine, but when we get to cotangent and cosecant, and you don't want to write the whole word, do you? Nope. Okay, so these are ratios. The ratio for sine is y over r. So the ratio is going to go here. So y over r. So I ask you the sine of theta. You would tell me it's y over r. Does anybody remember doing opposite over hypotenuse for sine? Is that the opposite? Yep. Is that the hypotenuse? Yep. Okay. Cosine of theta. We've abbreviated COS, but still say cosine, is the adjacent over the r, so the adjacent is x over r. Tangent of theta. We abbreviate it just TAN of theta is y over r. Not r. X. Now everyone understanding where I'm getting the x, the y, the r? Okay. I should have moved down here. Okay, now, if you look in this, which I will eventually have available to you to all look at, okay, this table goes straight down, and I don't want to make it straight down. I'm going to put things next to sine, cosine, and tangent. So, we're going to repeat the table next to it. So, cosecant, can't talk, is one you don't know. Cosecant of theta, we are going to abbreviate it CS SC of theta is R over Y. And Y cannot equal what? What can't Y equal? 0. Why not? Well, it wouldn't be a triangle, correct. Well, no, it would. Never mind. No, it wouldn't be a triangle, but there's places that it will equal 0. Why can't Y equal 0? Mathematically, why can't it equal 0, guys?
Because there can't be a 0 on the
Yeah, we can't divide by 0. Why didn't I say that over here?
Y is on top.
Y is on top. Can R, it's a radius. Could it ever be 0? No. It wouldn't even be a circle, would it? Okay, we always have to have a radius. Okay, so then, you know why I put cosecant next to here?
Because it's reciprocal.
They're reciprocals of each other. These are called the reciprocal functions. Okay, and then secant of theta is SEC. It is R over X, and X can't be 0. Oh, on tangent, what can't X be?
0.
0. Sorry, I should have said that. And the last one we have is cotangent. And we just put COT of theta. And that is X over Y. And what can't equal 0? Y. Okay, so that's what you're going to work with this assignment. So as long as you know X, Y, and R, are you going to get this done? Yep. Okay, we're good? Everyone got it? Okay, you got to know them. So if you have them down by Monday, all the better for it. Because then you can spend your time learning other stuff. Got it? Learn them. There's flashcards on Quizlet. Do them. And I'm not being, like, totally true what I'm telling you. Okay, so if I tell you to find the 6 trig functions of theta when, if theta is in standard position, what's that mean? What's it mean to be in standard position? It starts where? It starts on the positive x-axis. Okay? And the point -2, 3 is on the terminal side. Oops. How about I spell it correctly? Of theta. Okay, so find the 6 trig functions of theta if theta is in standard position and the point -2, 3 is on the terminal side of theta. So standard position means I start. You're going to need to draw things. I start on the terminal side, on the positive x-axis. Where is negative 2, 3 at?
And over there.
It's in the second quadrant, right? Okay, so it's somewhere over here. And there's this point, negative 2, 3. Well, if the point's negative 2, 3, well, I probably need to make a what? What do I need to make? What did I make? A right triangle. And always to the what axis? X. Okay, so here's my right angle. Well, if I know this point's negative 2, 3, do I know anything about this right triangle?
The x is a negative 2.
Okay, so the x is a negative 2. Now, really, can the length of a side of a triangle be negative? No, but we're not dealing with that. We're in the coordinate plane, so it can be negative. When I take it out of the coordinate plane, can it ever be negative? No. Okay, so what else do I know?
The y is
The y is 3. Well, in all of these things up here, I need x, y, and what? R. Well, can I find R?
Yeah.
How? You can. And I'm so excited that you said yes so quick. No. A squared plus b squared equals c squared. How do I know it's not a 45, 45, 90? Because these two sides aren't the same. If it was 3 and negative 3, would it be a 45, 45, 90?
Yeah.
Yes, but it is not. So a squared plus b squared equals c squared, right?
Mm-hmm.
So c equals the square root of 9 plus 4? Or r. Actually, we're not going to call it c. We're going to call it what? R. Well, what's 9 plus 4? 13. Can I simplify the square root of 13? No. So I just put the square root of 13. And now that I have x, y, and r, do I have everything I need to find all 6 trig functions?
Yeah.
Yes. Okay. So we're going to do sine of theta. And what you are going to do today, every single problem, you're going to write sine of theta and then tell me the ratio before you tell me the answer. Sine of theta is what over what? Y over r. And y is 3. And r is square root of 13. Oh, no. Can I leave square root of 13 in the denominator? No. Do you guys remember how to get it out? Yeah. Multiply by the square root of 13. So you guys will definitely start doing this without writing it all out. And I know you will, but I'm just going to write it all out, okay? So this would be 3 square root of 13 over 13. Because after you do that about 2 times, you're going to be like start doing it in your head, right? Now you might write 3 square root of 13, which is great, but then you won't write this. You'll just put it. Okay, then we'll do... do you want to go ahead right away and do cosecant? Or do you want to do cosine tangent and then do cosecant, secant, cotangent? Okay. So cosine is what over what? X over R. So it is negative 2 over the square root of 13. Do I have to write it all out, or can we just jump to the answer? Okay, so negative 2 square root of 13 over 13.
Wait, I thought we couldn't use a negative.
No, we're not in the square root. Like, these are ratios. Like, this triangle is in the coordinate plane, so we can have negative, and I'm not taking the square root of it. It's just showing me that I'm in the negative x-axis. Okay, like on a triangle, if I was out of the coordinate plane, it couldn't be negative. You're correct. Okay, so tangent is y over x. 3 over negative 2. And I'm going to put negative 3 over 2 because I cannot stand to have the negative in the denominator. But does it matter? No. If I tell you this is in the second quadrant, should you know that the negative is on the x and not the y? Yes, because in the second quadrant, y is positive, x is negative. I cannot personally stand to put a negative in the denominator. Anybody else? Makes me sick. Okay, what's the reciprocal of sine? Cosecant. So CSC, and I usually put them right next to each other. Does it help when I put a squiggly? How about I do them in different colors so you can see it? Okay, so cosecant.
Square root of 13 over 3.
Oh, nope. What's your ratio? R over y. And yes, it is the square root of 13 over 3. So you could look at your triangle, or could you just reciprocate this? Yes. While we're learning them, I'm going to encourage you to go back to the triangle because I don't want you to make a mistake and then make a mistake twice. Does that make sense?
Yeah.
Okay. And then what's the reciprocal of cosine? Secant of theta, which is r over x. So r is square root of 13, and x is negative 2, and I'm going to again put negative square root of 13 over 2. So by next week, if I say secant, you should know r is in the numerator, and you are definitely not going to put a negative r, are you? No. So you know the negative has to go on the x. And the reciprocal of tangent is cotangent, which is what over what? X over y. And so I have negative 2 over 3. Find the sine and cosine of 45 degrees. And I didn't tell you anything about it, did I? How rude of me. Well, do you know stuff about 45 degrees?
Yeah.
You know those ratios, don't you? So the first thing I'm going to do is draw myself a picture. And I'm going to put my 45 here. So what are the ratios for 45, 45, 90? What's cross? You guys remember? 2x. X square root of 2. And x square root of 2. But since this is some generic 45-degree triangle out there somewhere, no matter what I would do, everything, all those x's would like reduce out, correct? They'd like reduce down to 1. So we're going to put it in this imaginary circle that we call the unit circle. It is a circle of ratios. So everything reduces. This is a 1 point. And so, well, I won't put that. It's the unit circle. So the radius is 1 unit. So that's that x. Does that make sense? So we're going to get rid of all the what? X's. You will probably never, ever hear me say x squared root of 2 again. You will hear square root of 2, square root of 2, 2. Is there an applied x there? Yes. Okay. So we need to sine and cosine. So sine, and now we're not going to put theta because do we know what theta is?
Yes.
What is theta? 45 equals what over what? Ratio, give me the rule. Y over R. So it is square root of 2 over 2. the cosine of 45 degrees,
X over R.
x over r, which is
Square root of 2 over 2.
square root of 2 over 2. You've just learned 2 points is 75 points on your final.
What?
You have a chart with a bunch of angles that you have to know the sine, cosine, and tangent for on your final. And by mid-month next month, you'll know it, and you'll be able to work on it all semester to get 75 points on your final.
That graph for 75 points.
This,
Oh, yeah.
yeah. Or 16 angle, wait, 1, 2, 3,
Oh,
12,
yeah.
14, 12, 13, 14, 15, 16 angles. And you got to put them into radians. Yep,
So excited.
it is. Okay, so now, next example is,
Wow, that's
nope, just sine and cosine for this one.
Oh yeah.
I could ask you for all 6 and you'd go through all 6. But if I ask you tangent, it's going to be 1, isn't it? Because they're both the same. So, okay, this example is I want the 6 trig functions for 270. Okay, well, let's see. Let's talk about it. Draw a picture for us, right? Actually, someday you can draw. Look at my circles. I love my circles. Okay, so 270 degrees puts me here. Yes? Okay. Well, I told you the radius of this thing was like 1 unit, correct? So R equals 1 unit. And this is the unit circle. Can you see this pinky color? Okay.
Now your hand's over it.
Well, you don't have your x-ray vision working yet? Loser. Okay.
Then
So this is called the unit circle. So the radius is 1 unit. That 1 unit could be 10,648.6 feet, but it's still going to be 1 unit. Okay? So because it is 1 unit, what is this coordinate right here? Not 1.
Negative 1.
Well, how about let's go our y first. I mean our x first.
0.
0,
Negative 1.
-1. Okay. The point is 0, -1. And r itself would just equal 1. And why is it -1? Because you go what? Down and you're on the y-axis. But r is not ever negative, correct? Okay. So after today, I won't ever mention 1. These angles right here, I guess I probably should say this because I don't know if I missed it in the last 2. 0, 90, 180, 270, 0 radian, pi over 2, pi, 2 pi. Those are called quadrantal angles. Why do you think they're called quadrantal angles?
So there's 4 of them.
Yes, but do they also land on what makes the quadrants?
Yes.
Yes. You can't say it's in quadrant 1, can you? No. Or 2 or 3. They're in between. They're called quadrantal angles. So on every single one of these angles, what's this point going to be on the unit circle?
1, 0.
1, 0. What's this one going to be?
0, 1.
0, 1. What's this one going to be?
Negative 1, 0.
-1, 0. So all of those have that, and the radius is just going to be 1 unit. Where up here we used 2 because it was a what triangle?
Right.
Right, it was a 45, 45, 90. So that's 2 times the 1 unit. This is why this is a circle of ratios. Okay? So when we do all of these and put them over R, what are we putting them over? 1. So do you really even have to think about R?
No.
No, not till you reciprocate them, and then we'll go from there. Okay. So sine of theta, what's my ratio? Whatever what? Y over R. Well, what's Y? We're at 270 since we wrote all this stuff down. Sorry.
Wait, why
Why what?
you put theta now, not 270?
Oh, you're right.
Okay.
Theta is 270, but I should put what? 270? Okay. Sine of 270 is Y over R, which is what over what?
Negative 1 over 1.
Negative 1 over 1, so it is
Negative 1.
negative 1. Cosine of 270 is what over what?
X over R.
X over R. So it is.
0 over 1.
So it is
0.
0. Are we going too fast? Okay. Tangent of 270 is what over what?
Y over X.
So it is
Negative
negative 1
1 over 0.
over 0.
Which we can't have. 'Cause 0 can't.
So what's the answer?
Undefined?
Undefined. Can I just put UND?
Yeah.
Okay. Now, you guys do secant, cosecant, and cotangent on your own and try to pair them up without looking.
Wait, where do we get the 0?
Huh?
Where do we get the 0?
Right there.
She said don't look.
The X, if this is the point, the X is 0, yes? Try to do them without looking.
Maybe without looking.
Like secant, cosecant, and tangent without looking back. How'd it go? Good? Okay. So there's where we're going to stop today. I am going to go on to Friday's assignment. And I can't do that. So I am going to, let's see if I can edit it on my phone, because that would be the easiest thing. I will put the picture